In section 4.1, we will explore quadratic functions in more detail. Recall that a quadratic function is a function that can be written in the form f of x or y is equal to a times x squared plus b times x plus c, where a, b, and c are all real numbers and a is not zero. The graph of a quadratic function is a U-shaped graph called a parabola. The parabola can open either up or down, and the way that we can tell by looking at its equation is by looking at the leading coefficient a. If a is positive, the parabola will open up. If a is negative, the parabola will open down. The form that we've seen so far for writing the equation of a quadratic function is called the vertex form, so I want to make that note here. F of x is equal to ax squared plus bx plus c, again, is the vertex form for the equation of a quadratic function. There's another form for writing the quadratic function, and that is called standard form, and we'll explore that next. The standard form is f of x or y equals a times x minus h quantity squared plus k. These two forms can be interchanged. In other words, we can take the vertex form for the equation of a quadratic function and manipulate it so that it is converted into the standard form and vice versa. So these are just two alternate ways of writing the equation of the very same function. Let's look at standard form in more detail, and later on in this lesson, we'll come back to vertex form. When we have the equation of a quadratic function written in standard form, there are several quantities that will appear to us quite easily. We've already talked about the role of a, the leading coefficient. Well, it is the same a that we see here. If a is positive, the graph of the function will be a parabola that opens up. If a is negative, then the parabola will open down. We also see two new constants, h and k. H and k are actually the coordinates for the vertex of that parabola. So we see here that the ordered pair h comma k is the ordered pair that is the vertex of that parabola. Next, we see that the parabola is a symmetric graph. And the line of symmetry is a vertical line that passes through the vertex. Therefore, we say that the axis of symmetry is the vertical line with the equation x equals h. Now, the parabola will continue opening left and right indefinitely, so the domain of a quadratic function is always going to be the set of all real numbers. The range, however, will be restricted. If the parabola opens up, as we see here in this first graph, then the vertex will be the lowest point on the graph, and therefore the range will start at whatever that k value is, and then will continue upward without bound. However, if the parabola opens down, now the vertex is the highest point on the graph, and the range will go as high as k with no lower bound. We see that summarized here in these notes. Let's take a look at one example where we can explore the different parts of the parabola and of the domain and range. In this first example, we have f of x or y equals x plus 5 quantity squared minus 16. I want to point out what the values of a, h, and k are, since this is written in standard form. So what we have here is f of x equals, I don't see a coefficient in front of the parentheses, so I can assume that there is an implied positive 1 in front of that set of parentheses. Then we have x minus a negative 5 quantity squared and then a plus negative 16. I want to write it this way because I want to clearly identify the values of A, H, and K. So I see here that A is equal to 1. The quantity that's being subtracted from X is actually a negative 5 because we saw addition. So that's subtracting a negative number. So that means that H is equal to negative 5. And finally, what we're adding here in the end is a negative 16, so that will be the value of K. Now that I know these three quantities, I can more easily answer the questions below. Let's start with the vertex. The vertex has coordinates h, k. So in this case, the vertex is at the ordered pair negative 5, negative 16. The axis of symmetry is a vertical line that passes through the vertex. So the equation of that vertical line will be x equals negative 5. Because A is a positive 1, this parabola will open up. Now, let's look at the domain and range for now, and then we'll come back and explore the x and the y intercepts. I know that the parabola opens up, therefore the vertex is going to be the lowest point on the graph. That means that the lowest value of y will be negative 16, and there will be no highest value of y. Therefore, the range will go from negative 16 with no upper bound, traveling toward positive infinity. We said earlier that for all quadratic functions, the domain is the set of all real numbers. Now, let's go ahead and try to graph this parabola, and then we'll come back again and explore the x and the y intercepts. We know that this is going to open up, and that the vertex is at the point negative 5, negative 16. Now, I know these are really tiny grid marks, and they go up by ones. So let's see, negative 1, 2, 3. Let me make this bigger. That should help. So negative 5 for x, and then negative 16 all the way down here. I hope I got that right. 1, 2, 3, 4, 5. Oh, I missed it by 1. I'll go back and erase that dot. Okay, there's the vertex. Now, to find additional points on the graph, you can do an XY table, or you can remember from the parent graph of y equals x squared that we'll have a dot here and here, here, and here, here, here. And so this will give us a good idea of the graph. Now, we are going to want to find the x and the y intercepts. Let's find those algebraically, and that will help us get the rest of the graph clearly drawn. So by solving for the intercepts algebraically, what we're saying is we're going to set each variable equal to 0 and solve for the opposite variable. So if I set y equal to 0, for instance, I get 0 equals x plus 5 quantity squared minus 16, which means that 16 is equal to x plus 5 quantity squared. Using the square root property, I get that the positive or negative square root of 16 is equal to x plus 5, which means that we have plus or minus 4 is equal to x plus 5. And let's continue here to the right. If I subtract 5 from both sides, I get that x is equal to -5 plus or minus 4. X is either equal to -1 or x is going to be equal to -9. Now that's going to be quite helpful because that gives me 2 additional points to add to the graph. So we have -9, 0, and we have -1, 0. Let's go back and add those here to the graph. -9, 0 will be right here, and -1, 0 will be right there. Good. Now let's go back and solve for the y-intercept. This time we're going to set x equal to 0 and solve for y. So if we set x equal to 0, we have that y is equal to 0 plus 5 quantity squared minus 16. Y will equal 25 minus 16, or y will equal 9. That means that the ordered pair 0, 9 is also on the graph. Let's go ahead and add that to our graph. And then using symmetry, we can say that this point will be there as well. So there are lots of pieces of this parabola that we've been able to explore by means of the example. We found the vertex, we found the axis of symmetry, and I'm going to go ahead and add that here as a dashed line. The axis of symmetry is this vertical line that passes through that vertex, and it serves as the mirror that's creating the reflection on either side of that vertical line.